Somebody once told me the world is gonna roll me. I ain't the sharpest tool in the shed.
Okay, so this is located on page 146, and we're going to be discovering what it means to be a square root. And the directions say to draw an upright square in each section, and the squares should not be the same size. So in this first section, I'm going to draw a square that is a 1 by 1, meaning that all four sides of the square are 1 unit long. Okay, and then on the second one, I can't use a 1 by 1 anymore, so I'm just going to make a 2 by 2. And I can't use a 1 by 1 or a 2 by 2, so now I'm going to use a 3 by 3. And on the last one, we're going to make a 4 by 4. Now it wants us to find the area of each square. So what is the area of the first square? It is 1 square unit. So area is how many of those little squares can fit into the larger red square. I like to put these like dashed lines so I can see clearly. What is the area of the second square? It would be 4 square units. Okay, what about the third square? 9 square units. And what about on the fourth square? 16 square units. Okay, the next thing it wants us to do is to find the side length of each square. So all four sides of the first square are how long? 1 unit. They're all 1 unit.
I'm confused. How freaking not 2? Because it has the 2 dots in there. Why is it not
Distance is between the 2 dots.
Oh.
Yeah.
Okay.
What's the side length on the second square? It's going to be 2 units. What about the third square? 3 units. And the fourth square? 4. Then number 3 is saying, how does the area of each square relate to its side length? So we want to know, how do you go from one to the other? So how do you get area? What does area equal? What do you think? If you can just tell me. Go ahead. What do you got?
Oh, okay. I don't remember, but I'm pretty sure it is like the amount inside. Or is that not?
Yes, it is the amount inside.
Okay, so like the second one would be like 4 units, I guess.
Yes, but how do you, like, there's a, Z, help him out.
Isn't it length times width?
Okay, yeah. So the area of a rectangle is length times width, but these are squares. So they're side lengths, right? And they're the same. So it's going to just be your side length times the side length. There's a much nicer way to write this so that we don't have to write side length 2 times and without abbreviating anything. And it would be what? Side length squared, absolutely. So this is written in terms of area. What if I want to write it in terms of side length? For instance, if I say that the area is 16, how do you get to 4? Mathematically. What do you think, Carson?
Square root.
Absolutely. The square root of 16 is 4. The square root of 9 is 3. The square root of 4 is 2. So the square root of the area equals the side length. So side length equals the square root of area. Alright, turn this over. Because now we're going to talk about tilted squares. So when you are drawing your squares, please be careful and pay attention and make sure that you do them correctly. If you want to watch me do a couple before you do your own, that's fine. But we need all 4 of these squares to be filled in. So there's the first one. The next thing it wants us to do is to find the area of these. I'm trying to get a really good close-up so you guys can see how I do this. Okay, it is easier for me to see the area of a square that is not tilted. So that's what I focus on. I'm going to use a highlighter on this part because this is what I see in my mind. It's not what I write on the page every single time when I work one of these, okay? This is just how my mind kind of organizes the information. I see a square right there, okay? And then I see that this diagonal cuts that square in half. So this square, it has an area of 1. And then if I cut that in half, what is its area? Let's try that again. What is half of 1 square unit? Half a square unit.
So the area is 2.
So I see that this is 1/2, and then I can see that here's another section just like that one, and then 2 more. So you get 1/2, 1/2, 1/2, 1/2. What is the area? 2 square units. I do the same kind of thing on the next one, but instead of seeing a square, I see a rectangle. And that rectangle is 2 units or 2 square units. And it's cut in half by the diagonal. So the area would be 1. So I know every corner that matches that shape is going to have an area of 1 square unit. And then do you see how there's a square unit here? That counts as well. So this is 5 square units. See if you can do the third one. Give you a little bit of a head start. So when I draw my rectangle, I see that it's 3 square units. But if I cut it in half, that makes it 1.5 square units. So every corner section that is that shape has an area of 1.5 square units. And then I have 4 square units on the inside. So when I add them all together, what do we get? 10 what? 10 square units. Okay, try it with the fourth one. Okay, on this one, my rectangle has 4 square units, and I cut it in half, so that makes it 2 for that that piece. And so every corner that has that shape has an area of 2. And I have 9 square units in the middle. So how many total square units do we have? 17. Okay, now we want to find the side length. And remember, on the front side of this page, we wrote side length equals the square root of the area. So if the area is 2 and side length equals the square root of the area, what's the side length here? It's going to be the square root of, what's the area? 2. So it's going to be the square root of 2 units. The side length is just one dimension, kind of. So it doesn't get us squared. What about the second one? If the area is 5 square units, the side length is the square root of 5 and then units. What about the third one? Side length is equal to the square root of 10. Absolutely. And the last one, the square root is equal to,